Good morning, everyone. My name is Jamal Dinkeladi. I'm a CNRS researcher in the diverse team in ERISA in Rennes. And today I'm going to present you our near paper entitled On the Power of Abstraction of Model-Driven Coevolution Approach of Software Code. So before that, I just wanted to give a quick background on the work, which is based on model-driven engineering field. So MDE advises or promotes two main concepts. So instead of directly coding the software, we abstract from it by using different kind of models, and the different point of views are separated in different artifacts. This is the concept of separation of concerns. So you, at the end, you will have the architecture point of view in an architecture model, the requirement model, configurations, etc. And one of the scenarios of MDE is transformation. That remains fairly popular, which is also code generation from models or abstract models to the software code. And this scenario is well adopted in the today practices. So we find a lot of technologies, a lot of tooling support for this. For example, you have the EMF Eclipse platform, you have the GHipster that allows you to generate modern web applications, even the project schematics in Angular, Open API, and there are more technologies that do that. And now let's just focus on two scenarios, GHipsters and MF Eclipse, to better illustrate the issues that we are dealing with. So at the start, both allows the developer to create an abstract kind of model. So there's the meta model for EMF Eclipse and entity models for GHipster. And from that, what they do is they can generate the first round of code. So GHipster will generate modern web applications with backend and frontend, etc. Eclipse will generate a language, an API, adapters, an editor. And of course, on top of that, you add, or developer has to add additional code to code the functionalities that are needed in the software. And ideal world, of course, you want to put effort in the models, either the entity model or the meta models, and then you refine and code. But in reality, it doesn't work like this, and developers have to change and to evolve the software. And whenever they evolve at the model level, of course, you can regenerate the code, but they have also to update the code that have been added, which may be broken. And in this near paper, we call for a better investigation of this evolution at the abstract level of the models down to the code that has been added by the developer. And an ideal scenario, we have to leverage on this power of MDE, so to leverage on what have been changed in the model level to run impact analysis and find this code that has to be co-evolved accordingly, and to automate this process as much as possible. So just to wrap up this presentation, actually today MDE and generative approaches are reality, and many technologies already support this. I named GHipster, Eclipse, schematics, Open API, low-code platforms as well. And we noticed that in those approaches, design domain evolutions will lead to coevolutions down to the code. And supporting this process of evolution and coevolution is still missing piece that can further ease the adoption of these tools that we believe. Okay, thank you very much for your listening, and hope to chat about this with you.